Today, we are going to talk about compound probability. First, let's review what is probability. Probability is the likelihood that an event will happen. The formula for probability is the number of outcomes, favorable outcomes, is what they're asking for, out of the total number of possible outcomes. We discussed this last week when we talked about simple probability. Let's review simple probability. Simple probability consists of one event. Here's an example of simple probability. There are 10 marbles in a bag. 4 are blue, 6 are red. What is the probability of selecting a red marble? So, what is the P of red? Remember, that's how we write probability of red. Well, we know there are 10 total marbles. 6 of them are red. We need to simplify by dividing top and bottom by 2. Or you can type it in your calculator. This gives you 3/5. Change it to a decimal, 0.6, and change it to a percent would be 60%. This is what we did last week. Okay, so this week we're going to talk about compound probability. Compound probability consists of 2 events. The probabilities of the 2 events are multiplied together. The 2 events are either independent or dependent. First, let's talk about independent events. An independent event is where the outcome of one event does not affect the outcome of the other event. So it doesn't change it. Here's an example. What is the probability of landing A on the spinner and then landing B on the spinner? So first, we're going to write down the probability of landing A. The probability of landing A would be 1, 2, 3, 4 A's out of 1, 2, 3, 4, 5, 6, 7, 8. 4 out of 8. There are 8 total sections on the spinner, and 4 of them are A's. So that's 4 out of 8. Simplify. And this would give us 1/2. Now we need to find the probability of spinning B on the spinner. So the probability of spinning B, we already know there's 8 total sections. There's 1, 2 B's on the spinner. So when we simplify that, that becomes 1/4. Remember at the top when we discussed the definition of compound probability, we said the probabilities of the 2 events are multiplied together. So we have to take our 2 events, 1/2, and multiply it to 1/4. If you've forgotten how to multiply fractions, remember when you multiply fractions, you multiply straight across. So we're going to do 1 times 1 is 1, and 2 times 4 is 8. Compound probability is written like this. The probability of A, then B is 1/8. That's how you'll see that written. The probability of A, then B is 1/8. Okay, let's do another one. What is the probability of landing on C and then on B? So they want the probability of C, then B. First, we need to find the probability of C. So the probability of C equals how many C's are on. I'm going to erase my old ones from the first one. So how many C's are on the spinner? One, two. So that's 2 out of 8. And if we simplify, that's 1/4. Now we need to find the probability of B, which we did up top. We'll count again. There's 1, 2 B's out of 8. So simplify, that's 1/4. And again, compound probability is multiplied. So I'm going to take 1/4 times 1/4. Equals 1/16. So the probability of C, then B is 1/16. So that is independent. That is an independent event. Now we're going to talk about dependent events. Dependent events are when the outcome of one event does affect the outcome of the other event. Here's an example. What is the probability of selecting a star, not replacing it, then selecting a heart? The reason I put a rectangle around not replacing it is those words is what makes this a dependent event. The fact that it has not been replaced changes the number of items that's in the bag. So what they're asking us to look for is the probability of getting a star, then a heart. First, we need to find out the probability of getting a star. So let's count the items in the bag and then how many of them are stars. So there are 1, 2, 3, 4, 5 items in the bag, and there's only 3 stars. So 3 out of 5 items, and 3/5 is already simplified, so we don't need to simplify that anymore. Now we're going to find the probability of getting a heart. So here is what makes it dependent. The fact that when I pull the star out, it is not replaced changes the number of items in the bag. So there are no longer 5 items in the bag. There are only 4 items in the bag. So that means 2 hearts out of 4, which simplifies to 1/2. Now I can still take my 2 fractions and multiply them together. 3/5 times 1/2 equals 3/10. So the probability of getting a star, then a heart, is 3/10. Let's look at this next example. Last example. What is the probability of selecting a blue marble, not replacing it, then selecting a green marble? So here we have our bag of marbles. I labeled the marbles B for blue, R for red, G for green. What is the probability of selecting a blue marble, not replacing it? That is very important. That's what makes it dependent. Then selecting a green. First thing we have to do, probability. I'm going to write out my probability statement. Probability of blue, then green. What is that going to be? First thing we're going to look for is the probability of getting blue. So I have to count. First, I need to count how many marbles are in the bag. So we are going to count how many marbles are in this bag. Okay, so there are 20 marbles in the bag. How many of those marbles are blue? One, two, three, four, five, six. 6 out of 20. Can this be simplified? Yes, it can. 3/10. Now we need to find the probability of getting a green. So let's count. 1, 2, 3, 4, 5. That's 5 out of how many? Was the blue marble replaced when we pulled the blue marble? No, it was not. Since it was not replaced, there are no longer 20 marbles in the bag. There are 19 marbles in the bag. So there are 5 out of 19 marbles in the bag. Now we are going to take our two fractions, 3/10 times 5/19. Okay, so this becomes 15. 3 times 5 is 15. 10 times 19 is 190. And this can be simplified. It simplifies to 3/38. So the probability of getting a blue marble, not replacing it, then a green marble is 3/38.